Hi all, this is Mr. Yeager, continuing with physical science and compounds. We have just finished up, hopefully the last video you watched was why we form bonds. And again, it's the idea that the elements want to get to a lower energy state, essentially. And they do that by basically trying to get to that octet rule, where we have 8 valence electrons or a full outer energy level. So we said we can get those electrons either by gaining, losing, or sharing. What we're going to look at today is the gain-lose part. They go hand in hand. When one gains electrons, that means another atom is losing electrons. And when they do that, they're going to form what we call ionic bonds. Ionic bonds. Going to get a different color here. Okay? They form these ionic bonds. So near the end of last video, I started talking about how metals and nonmetals form cations and anions. So cations, they're positive ions. This is because these guys lose electrons. And this is done by metals. Anions are elements that gain electrons to get a full outer energy level. And this is done by nonmetals. So therefore, when they form these charges, we know opposites attract. Opposite charges attract. A positive cation is attracted to a negative anion. Now, before I move on, there's one thing I probably should have done during the last video. We started talking about how different atoms have charges, and you can figure that out based on where they are in the periodic table. The thing is, I want to very quickly show how to write charge, how to write ions, okay? Because that's going to be part of this ion naming and formula writing, okay? So how do we write an ion? The way we write an ion is we write the chemical symbol, okay, the chemical symbol, all right? Actually, I'm going to go over here. Sorry, I'm going to switch this up a little bit, okay? You write the chemical symbol, and then you write the charge as like an exponent written above. Wow. My spelling's bad. The charge above the symbol up above to the right, okay? And so what we would do is, I'm going to erase that. I'm going to draw a little periodic table here. Okay? We look at this again. Group 1, positive 1. Group 2, positive 2. We're not going to worry about the middle ones too much. Group 3, positive 3. Group 4 is the switch. Group 5 is then negative 3. Groups, I guess 15, 16, sorry, is negative 2. And group 17 is negative 1, the halogens. Okay? So what if I said, hey, I wanted you to write the ion for oxygen. Okay, oxygen. Oxygen is in group 16, so it has a negative 2 charge. So what we would do is we would write O and then negative 2. Or O2 minus. Either one is accepted. You might see them written either way. Okay? Let's say I wanted to know what magnesium was. Magnesium, what's the ion for magnesium? Magnesium's in the second column, so this would be Mg plus 2. Okay? So that's how we write an ion. Now it's an ion. Now what does this mean? Okay? This is first off a cation because it's positive. And it means that it has lost 2 electrons. Again, I know that can get confusing for people, but electrons are negative, so if I lose 2 electrons, I'm becoming positive. This oxygen is an anion, and it has gained 2 electrons. So what's going to basically happen is these 2 elements, magnesium and oxygen, would be attracted to each other. And we're going to have to give that a name, and we're going to have to give that what's going to be called a chemical formula in a moment. But one other thing I want to just quickly show. What if I have an element from like the halogens, FCl, bromine, iodine, okay, going down this list, okay? Or I have somebody from the first column, HLI, I think it's Na, right? Okay, K, all right. What do I do when it's plus 1? There's one thing that I want to make sure you notice here. And actually, this is going to be something that carries throughout all of physical science chemistry. Okay? Is when the objects just have only one charge, positive 1 or negative 1. Okay? we don't actually write it as F negative 1. We actually just write it as F negative. The idea is, I know F is negative, and it's assumed, if I'm writing that it's negative, it's at least 1. Okay, that it's at least 1. All right? So we almost never write the number 1 in chemistry. Okay? With any of the alkali metals, Li plus and A plus, K plus. We never write the number 1 with it. Hydrogen would be H plus. So it's the only one we don't write for. Now again, if it's coming out of column number 3 where we have nitrogen or phosphorus, okay, we would write nitrogen minus 3, phosphorus minus 3, because we need to now show it's more than negative 1. Well, how much is it? 3. Okay, so I wanted to kind of go back and do that. I should have covered that in the last video, but there it is now, and we're going to be using it in just a moment. Okay, so here we go, forming these ionic bonds now. Okay, so what we're going to write is something called a chemical formula. A chemical formula. And this is the way that we abbreviate compounds. Instead of having to write out the entire name and write out all the numbers involved with them, excuse me, we just write a chemical formula. And so what the chemical formula has, as you see with the arrows, is you write the chemical symbols, one after the other, and then you write numbers down below. So again, I know this might get confusing where we're writing numbers up high and some down below, but we're going to write subscripts, and what this is telling us is the number of atoms in the compound. All right. So a chemical formula is written with symbols, chemical symbols, and then subscripts, little numbers that go below and after the chemical that's referring to. So what this compound is saying is I have 2 aluminums and I have 3 oxygens in this formula. Okay, 3 oxygens in this formula. Now, this is a correct formula, so how do we get that? We're going to get to that in a second. How do we know when aluminum and oxygen combine, there's going to be 2 aluminums for every 3 oxygens? We're going to see that. I just wanted to show you what a chemical formula looks like. The other thing is, the metal is always written first, the nonmetal is always written second. The way I try to show that is on the periodic table, metals are to the left, nonmetals are to the right, and when I read left to right. So I would read the metal, then the nonmetal on the periodic table. Okay? So metals are always written first, nonmetals are always written second. Okay? Sometimes we say you do the cation first, and then the anion second, because again, metals are cations, nonmetals are anions. Okay? So here we go. So jumping right into it, the only way to really learn how to write a chemical formula from a name is just to be basically doing a problem. So I got this kind of step by step, and hopefully you become faster and faster so you don't feel like these are taking a long time. But again, this is my strong recommendation on how to create these formulas. There are other methods out there, you can by all means see those, but if you're coming to me with a question, I'm going to make you kind of go through these steps to see why you're doing what you're doing and why you get the answer that you do. So if we start off, I'm giving you a compound, magnesium chloride. This is ionic compound. I know that because this is a metal and this is a nonmetal. Magnesium is a metal, chloride or chlorine is a nonmetal. So when these two things combine, I have an ionic compound. The first thing I recommend people to do is just write the charges right above the elements. Write the charges right above the elements. So if you have a periodic table, we would look for magnesium. Magnesium's in column 2. That means it has a charge of +2. And so I would tell my students to write that right above the name. Chloride. Now, you might see it sit there and be like, there's no chloride, but there's chlorine. Hopefully you can kind of see pretty quickly what element we're referring to. Chlorine is in group 17, the halogens, the second to last column next to the noble gases. It has a charge of -1. So there's a reason why we're doing this. So the first step is just identify the charges involved with the compound. +2, -1. So that's on the next page here. Okay? What we'll then do is write the chemical symbol for both elements. You can bring down the charge with it. Write it as an ion, like I just did at the beginning of the video. So magnesium, magnesium would be Mg plus 2, and chlorine would be Cl minus. Again, we try not to bring the 1 down. Okay? So we already got one part of our chemical formula. We got the two symbols set up, Mg and Cl. The thing is, for an ionic compound, for every ionic compound, the overall charge of an ionic compound has to equal 0. The ionic compound, after all the elements are put together, is electrically neutral. So this is again why we're about to do our next step. We got to make this compound neutral. Otherwise, other things are going to be attracted to it, or it's going to be attracted to other parts, and then there are going to be more elements coming at it. So we don't want any other elements to get involved other than magnesium and chlorine. So we figured out their charges, and now we wrote them as ions underneath the name. Okay, or next to the name, it doesn't have to be underneath the name. So that's what we got on the next page. So here's the little trick, okay? We can sit there and really try to figure out, and I mean, I would say it's definitely recommended to try to go, okay, what is making this overall charge 0? But there's a little trick we can do to try to speed this up, especially for physical science. We do something called the crisscross method. We crisscross the charges. So what we're going to do is we basically take the 2 plus, and we're swinging it down to behind the Cl. We're bringing the number down, not the charge, okay? So 2 is going to come down after chlorine. And then I know this is kind of weird because there's no number there, but again, what is the number we're assuming is right there? Is 1, okay? So we're basically, by crisscrossing the charges, we're figuring out how many atoms do we need. Sorry, how many atoms, not just how atoms. How many atoms are needed to balance this formula, to make it overall electrically neutral, okay, to make the overall charge 0, and I'll show that a little bit more too. So we just crisscross the numbers, all right? We crisscross the numbers, okay? So what happens with that is, as you can see here, we get rid of the 1. We do not write 1, okay? No 1s, okay? 0 1s. So if we wrote this as Mg1Cl2, that would technically be marked wrong. Okay, so we don't include 1s. If the atom is there, if I have Mg written here, I know that means it's there. Now I'm just saying, do I have more than 1? So what I have here is I have 1 Mg, and what's this saying? I have 2 chlorines. So 1 Mg and 2 chlorines. All right. Now, what we can do with this, and I put a star next to this step because this is one that's really important that you have to check, but you might not have to do anything. We have to confirm what's called the lowest ratio. In other words, is there a number that I can divide into 1 and 2 that can make that smaller less than 1? Okay, so that I can make that number closer to 1. I cannot have decimals. No decimals, okay? No fractions, nothing like that, okay? What I'm trying to say is, if I have 2 numbers that could be divided by the same number and still get a whole number, I do that. So I try to reduce it down. The thing is, one of the elements is 1. I can't get smaller than that. So this right here is already reduced. MgCl2 is already reduced, and that means I have my right formula. Okay, that is the correct formula involved there. Okay, sorry, we'll come back to that in a second. All right, so MgCl2 is my correct formula. We will see in a minute what I mean by we have to reduce. I'm not going to mess around with it right now. There's examples on the next page. But this right here is electrically neutral. The overall charge is 0. Why? Because I have 1 Mg2 plus and I have 2 Cl minuses. So how much charge do I have here? I have plus 2 plus 2 negatives, so negative 2, and that equals 0 charge. So that's another way we can look at it. And instead of having to write all of these atoms out, we just write the chemical formula, MgCl2. Okay? Now again, I know if we're having chemistry people watch this, you might be going, that's a formula unit, so technically the atom, this compound is made up of a ratio of Mg and Cl2, 1 Mg for every 2 Cls. Physical science, we don't need to worry about that as much. So let's practice a couple problems, okay? So sodium. Sodium has a charge of +1. Fluoride, fluorine, that has a charge of -1. How am I figuring this out? I look at a periodic table and I go, sodium's in the first column, +1. Fluoride's in group 17, right next to the noble gases, -1. I then write out the two symbols. Sodium is Na, fluorine is F, so plus, minus. Then I technically crisscross the two, but what am I crisscrossing? 1 and 1. So what's my formula? NaF. Can I get anything less than 1? No. 1 is the smallest number we can get in any chemical formula. Okay? So that would be my formula for sodium fluoride, NaF. This is also where it's important that we write these symbols correctly. If you wrote NaF, that looks like there's a nitrogen, there is no element that's A, and then there's a fluorine. So we got to make sure we write the correct element. So you have to have that small letter in the second, if it's the chemical symbol's 2 letters, the second letter has to be lowercase. What about calcium oxide? Calcium is in the second column, so it's +2. Oxygen, oxide, that's in group 16, 2 away from the noble gases, so that's -2. So then I have Ca +2 and O -2. I crisscross those charges, and I get an answer of Ca2O2. This is where the reducing step has to come into play. You're currently telling me I need 2 calciums and 2 oxygens so that I equal out to 0 charge. That is not true. Okay? What can I divide both these numbers by? The answer is 2. Basically, all you're trying to figure out, guys, is can you divide by 2, 3, or 4? I cannot see that you're going to go higher than that usually. 2, 3, or 4. So I can divide both of these by 2. So my actual formula is CaO. That would be this is the correct answer, CaO. So this is where the crisscross method can mess you up. If the charges are the same or are multiples of each other, we're going to have to reduce the final answer. We can't leave it as Ca2O2. Why? This is Ca +2. This is O -2. Some people probably saw this at the beginning. Hey, each one is already equal, so I only need 1. +2 plus -2 is equal to 0, so I only need 1 of each, okay, to have the overall charge 0. All right? So that's basically the steps for going from name to formula. So now let's do the opposite. What do we do if I need to go from formula to name? Okay? So here I have a compound. I have a chemical formula, a compound, K2O. The nice thing is for ionic compounds, the naming is pretty simple. All right? Again, how do I know this is ionic? This is a metal, potassium's a metal, oxygen's a non-metal, because soon we will have to identify first what type of compound I have, because the type of compounds have different naming rules. It turns out for ionic compounds, the metal just keeps its name. So what's K? K is potassium. Okay? And then the non-metal, I have to add the suffix "ide." So some elements are kind of difficult to do, some are easy. I'll probably just go through all of them for you. All right? This is oxygen. We don't call it oxygenide. We would actually just call this oxide. All right? One thing we don't care about is we don't care about how many elements each one is, because the charge is what's helping me do that. So I don't need to say I have 2 potassiums and 1 oxide. It's just potassium oxide is the name here. Okay? Which is, do I do that on the next page, basically? Okay, so this one is just called potassium oxide. Okay? What about these two? See, that's why there's not much to really say. What's Li? Li is lithium. It's a metal, so it just keeps its name. Lithium. Cl is chlorine, so I'm going to change that to chloride. So the answer is lithium chloride. This one down here, Sr, is called strontium. It's a metal, so it keeps its name. nitrogen. Nitrogen is going to become nitride. Not nitrogenide, nitride. Okay? We don't worry about the numbers. We're not going to add a prefix or anything like that. It's just called strontium nitride. Okay? So if I go through the elements really quick that we have to change, the nonmetals, the most common ones are these. It'll be F, Cl, Br, I. It'll be O and S. And then it'll be N and P. These are your most common ones. Fluorine is just called fluoride, not flouride, please. Chlorine is chloride. Bromine is bromide. And iodine is iodide, not iodinide. Okay, iodide. Oxygen, we already said, is oxide. Sulfur is going to be sulfide, not sulfuride. Sulfide. Phosphorus is going to go down to phosphide. That's another tricky one usually for people that I usually see phosphoride. And then we already saw this. Nitrogen is nitride. Those are your most common, what's that? 8 elements that you're going to use as nonmetals in almost all compounds in this course. All right. Maybe you run into Se, that's selenium. That would be called selenide, but I would be very surprised. Okay. You should know fluoride, chloride, bromide, sulfide, oxide, phosphide, and nitride. Those would be the main ones to know. Okay. Now, there is one special situation that can come up, okay, is where we have transition metals. As I said, transition metals, they're kind of funky. We kind of just made a general statement that they have 2 valence electrons, but they have multiple charges, which is why we don't mess with it. So with transition metals, what we're saying is the same metal can have multiple charges. So you can see right here, I have copper plus and copper 2 plus. I have iron 2 plus and iron 3 plus. Don't worry about why it's one or the other. More just make sure we know how to name it. The way we name these is we just write the name of the element. The metal keeps its name, copper. But we're going to use Roman numerals to illustrate the charge. So copper I for 1. This one is copper II. Okay? Down here I got iron 2, II, and then we got also sorry, just a second. All right, sorry about that. So again, you just add the Roman numeral that represents the charge of the atom, which I think I have written on the next page. Okay, we just use Roman numerals. You only need to know Roman numerals up to about 7. So remember that if we do 1, 2, 3, 4, 5, 6, 7, 1 is I, 2 is II, 3 is III, 4 is IV, 5 is V, 6 is VI, and 7 is VII. Okay? So what we have there is, again, the Roman numeral is representing the charge of the atom. The atom keeps its name. The Roman numeral represents the charge. So copper 1 has 1 charge, plus 1. Copper 2 has 2 plus. All of these charges are positive because this is only going to be for metals. Okay? We don't do nonmetals this way. This is only transition metals. Okay? So if we try a couple of them out here, okay, what we would do here is we'd say this. We have iron 2 chloride. So this is from name back to formula. So how would I do this? I look at iron 2. 2 is the charge for iron, so this is plus 2. Chlorine's a halogen, that's negative 1. So this is Fe, this is Cl, plus 2 minus 1. Okay, sorry, shouldn't have the minus. 1, minus. Crisscross the charges. This means Fe, 1. Cl2. Don't need to reduce. FeCl2. That's already reduced. How about the next one? Scandium-3. Yes, I have no idea. You might not know what scandium is. That's fine. It's 3. That just means plus 3. Oxygen has a charge of minus 2. So this is, I'm going to put it over here. Sc plus 3. O minus 2. Crisscross the charges. Sc2. O3. There's your formula. Manganese 7 oxide, that's a mean one. 7, that's plus 7. This is minus 2. I crisscross the charges again. I'm going to speed this one up. Mn2O7. All right, and I can't reduce it. I can't divide 7 by 2. That's going to give me 3.5. I can't have a decimal. All right, so that's basically what you're doing with writing formulas for transition metals. Okay, in physical science, you're not going to have to go the other way. That would be more of a chemistry thing where you have to figure out the charge. This one would be if they happen to give you a name with the Roman numeral after it, you know this is the charge, the positive charge, okay, of the atom. And that is it. All right? Thank you very much.